Hello, my name is Dr. Armand, and today I'm going to be giving you a little bit of a tutorial on how to draw acetylsalicylic acid on the WebCSD. And so let's go ahead and get started with this tutorial. So just a disclaimer here, when we provide this video, this is actually an overview of how to use the WebCSD chemSketcher, and in particular how to draw acetylsalicylic acid. This is updated. The chemSketcher is updated from time to time and may be slightly different from the version shown here because periodically they update the chemSketcher. It may not be the same as the one I use. However, the basic process for drawing your structure will be the same, although some functions of the chemSketcher may be different. And again, I'm using the WebCSD chemSketcher as of spring 2023. So just keep that in mind when you're watching the video, is that from time to time, they do update the chemSketcher, and what I'm showing you will work. However, some of the buttons or functions may be slightly different. So with acetylsalicylic acid, it looks like this. And so this is the chemical structure of acetylsalicylic acid that we're going to draw on the WebCSD, and just a few notes about some of the groups on this molecule. And again, this is tailored to the Gen Chem 1 students, and they may not be familiar with, example, what an OH group is, or a CH3 group is, or the benzene ring. And so here, this is referred to as a methyl group. Sometimes the methyl group is denoted ME. So if you see ME instead of CH3, that's also referring to a methyl group. And so again, the methyl group is sometimes denoted in a structure as Me. So you see an Me here. This is also referring to a methyl group. Now, another way you can draw the methyl group instead of just writing CH3 is by drawing a carbon that's attached to 3 hydrogen atoms. So this would be inserted here. And this is another way that you can see a methyl group. This is another example of how a methyl group could be illustrated. So again, we got 3 different things here. We can illustrate it as CH3. Sometimes it can be written as Me. That refers to a methyl group. Another way we can draw it is by using a carbon and attaching it to the 3 hydrogens. And this carbon here, or this bond here, is this bond right here. So this is a little bit of introduction into the methyl group. Next, we have the carboxylic acid group here, the COOH. And this OH group in particular is called the hydroxyl group of your carboxylic acid. And the hydroxyl group, again, can be drawn as OH, or we can also draw it as an O single bonded to an H. And again, this bond here, let me use a different color. 1 second. This bond here is this bond right here. And so again, OH groups can be illustrated, 2 different ways. You can write it as OH together, or you can write it as an O with a single bond hydrogen. Lastly, we want to look at this 6-membered ring here called the benzene ring. And as we'll see on the next slide, benzene ring has a few different names that we're going to look at a little bit more in depth, and it has some alternate drawings of the benzene ring. So with the benzene ring, as I mentioned, it has other names. It could be called a 6-membered aromatic ring. This is one alternate name for a benzene ring. It could also be referred to as a phenyl ring. So again, these are alternate names that can be described for a benzene ring. And if you end up taking organic chemistry, you'll learn the difference between these names. Secondly, there are many different ways to draw a benzene ring. So one way to draw it is by showing the double bonds, the single bonds, and also the hydrogen atoms. This is one way a benzene ring, aka phenyl ring, aka six-membered aromatic ring, can be drawn. We can also draw it like this. This is called the skeletal structure, where now we've removed the carbon and hydrogens and just show the carbon-carbon bonds. So number one, number two. Thirdly, we can replace, since this is a benzene ring, and this benzene ring has what we call resonance, that means the double bonds flip back and forth between different positions. We can remove these bonds here, and we can replace it with a circle. So this is a third way a benzene ring, aka six-membered aromatic ring, aka phenyl ring, can be drawn. And so this circle ring, or this circle inside the ring, indicates that these double bonds are alternating. They have resonance. A fourth way you can draw the benzene ring, aka six-membered aromatic ring, aka phenyl ring, is by putting dashes instead of the circle. So these dashes indicates resonance, and that means that the double bond flips back and forth. So these are all different ways that a benzene ring, aka six-membered ring, aromatic ring, aka phenyl ring, can be illustrated. So keep this in mind when you're using the WebSketcher on the chemSketcher on the WebCSD, as from time to time they may change some of the terminology. So with that note, now we'll flip over to the WebCSD chemSketcher and show you how to draw acetylsalicylic acid. So now we're at the WebCSD, the Cambridge Structured Database WebCSD, and we're at the chemSketcher. And so what we're going to do here is we're going to draw acetylsalicylic acid, and we're going to see what structures have this molecule in their crystal structure. And so remember, we showed you acetylsalicylic acid on the previous slide. And so the first thing we want to start with when drawing acetylsalicylic acid is we're going to come over to this menu here that has different rings. So you see here, this is a drop-down menu right here. So we're going to click on the drop-down menu, and we're going to select the appropriate ring for us. And so to begin with, the appropriate ring is the one, as I mentioned earlier, the six-membered aromatic ring. Again, this is be called many different things. It's also referred to as a phenyl ring and also a benzene ring. So again, six-membered aromatic ring is a phenyl ring, aka benzene ring. And this is the ring you need to pick. This is the correct ring. Do not pick the one without the dashes. See the dashes in it? You click on it, and we can put it in our chemSketcher. So that's the first part. We have now the six-membered aromatic ring. Again, drop down, you select the one that says six aromatic ring. Next, we're going to draw the carboxylic acid. So we're going to click on the single bond. So we click on the single bond, we click and drag, and we're going to first make the structure of it. And so if you click and drag over a single bond, so now we have the basic structure. Next, we're going to click on double bond. We're going to put a double bond right here. And so here in our carboxylic acid group, we need some oxygens. This is an oxygen, and this is an oxygen. But if you remember, this oxygen had a hydrogen group on it. So now we're going to select single bond and replace that with a hydrogen. So it looks like this. So that's the carboxylic acid component of acetylsalicylic acid. Next, we're going to draw the ester portion, or the ester group on this molecule. So again, we're going to start with single bonds. We're going to draw the basic outline. Let me undo that. Let's first select carbon, single bond. So click single bond, and we're going to click and drag. We're going to make the backbone of this ester group. So now, again, this carbon to this carbon, we're going to replace this carbon and this carbon with oxygens. Next, this carbon to this oxygen needs a double bond. So this is what we call the carbonyl group of the ester. Next, this carbon down here is a methyl group. Remember, that was the CH3 group. So methyl group can be drawn, if you look back a few minutes ago, it can be drawn with a carbon with 3 hydrogen atoms bound to it. So we're going to click on single bond. We're going to click on hydrogen, place hydrogens, and we're going to add 3 hydrogens to this. And again, this represents the methyl group. Lastly, we want to add, to minimize the number of results hits that we get, we want to put the hydrogens on these carbon atoms. And so this is what your molecule of acetylsalicylic acid should look like. Just keep in mind that this is the methyl group. We write that we talked about on the previously. And this is the OH group, the hydroxyl group that we talked about previously as well. So if your structure looks like this, then it has to look, again, exactly like this. If it looks exactly like this, you're ready to do a substructure search. And again, I'm currently using the Sketcher version 1.9.32. Again, in the future, they may have updated it, so it may not look exactly, the functions may not look exactly like the functions I use here, namely the drop-down menus, but the overall structure should look the same. So now we're ready to begin our substructure search. So we come down here, click on substructure search. And if we did it right, it'll find some results. So in this case, it found 58 results. So now you have to scroll through these 58 results and see which ones are just only acetylsalicylic acid. So again, we're looking for these structures that are only acetylsalicylic acid. So again, let me write that here. Look for structures that are only acetylsalicylic I didn't spell that right. Give me 1 second. My bad. Acetylsalicylic acid. This is important. So again, we're only looking for those structures that are acetylsalicylic acid. And how do you know if they only contain acetylsalicylic acid? When you look at the chemical diagram, whatever you have drawn is illustrated in brown. So here, the Me, like I mentioned, Me is another way to say methyl group. So if your structure just contains this, it's acetyl salicylic acid. If it's other components that are not identified as brown or not highlighted as brown, this means there are other components in the structure. So for example, If I click on this one called AirFox, and I scroll up, see AirFox, this ref code AirFox, this is the brown component. So this is acetylsalicylic acid. However, it has this in it. So this is not a crystal structure of just acetylsalicylic acid. So again, in the chemical diagram, we're only looking for the structures that contain just what we've drawn. Again, that's highlighted as the brown, and in the 3D viewer, it's highlighted as green. So we're only looking for the crystal structures. Again, we're only looking for the crystal structures that just contain acetylsalicylic acid. So this structure does not contain just acetylsalicylic acid. It contains other compounds. So again, if I click on this one again, it only contains our compound because that's the only thing highlighted in the chemical diagram. Secondly, in the 3D viewer, it's highlighted as a green color. So if you only see this, then it counts towards the being a crystal structure of only acetylsalicylic acid. And so that's how you draw the structure of acetylsalicylic acid using the WebCSD chemSketcher. And so that concludes today's little short video on how to use the WebCSD chemSketcher to draw the structure of acetylsalicylic acid and to search the database for those structures that only contain acetylsalicylic acid. And again, this was the chemSketcher that was used in spring 2023. So future versions of the future updated versions may be slightly different, but the overall structure is what you want to draw on the chemSketcher. So on that note, Dr. Armand signing off. Until next time.